Now, the 2015 probability question, an experiment consists of throwing two fair standard six-sided dice, noting the sum of the two numbers thrown. If the sum is 9 or greater, it is recorded as a win. If it's 8 or less, it is recorded as a loss. So 9 or greater is a win. Complete the table below to show all the possible outcomes. This is a fairly simple sample space. Reminder that a sample space is when you write out all the possible outcomes. So if you roll a 1 and a 1, then that's 2, which is 8 or less, so that would be a loss. 1 and 3 is 4, that's a loss. 1 and 4 is 5, that's a loss. 1 and 5 is 6, that's a loss. And 1 and 6 is 7, that's a loss. Sorry, I should just, it's very hard not to write down exactly what you say. So these are losses. So that's a loss. 4 is a loss. 5 is a loss, 6 is a loss, 7 is a loss, and 8 is a loss. Loss, a loss, a loss. 5 and 3 is 8, that's a loss. But 6 and 3 is 9, so that's a win. Now this will be 5, 6, 7, 8. Now this will be 5 and 4 is 9, that's a win. So 6 and 4 is 10, that's a win. So 6 is a loss, 7 is a loss, 8 is a loss. Now 4 and 5 is 9, that's a win. 5 and 5 is 10, that's a win. 5 and 6 is 11, that's a win. 6 and 1 is 7, that's a loss. 6 and 2 is 8, that's a loss. 6 and 3 is 9, that's a loss. Sorry, beg your pardon, that's a win. Win. And 6 and 4 is 10, that's a win. 6 and 5 is 11, that's a win, and that's a win. So anything with a W is a win. Find the probability of a win on one throw of the two dice. So if the sum is 9 or greater, it's a win. So how many wins do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of a win, there are 10 favourable outcomes. There are a total of 36 outcomes. So that will be 5 out of 13. Find the probability that each of 3 successive throws of the two dice results in a loss. So if the probability of a win is 5 and 13, then the probability of a loss is, sorry, that's 5 over 18, beg your pardon, 5 over 18. Then the probability of a win is 5 over 18. The probability of a loss is 5 over 13. And we're looking for a loss and a loss and a loss. So we multiply, and means multiply in probability. So we're looking for 3 losses in a row. So that will be 0.3767. Correct 4 decimal places. The experiment is repeated until a total of 3 wins occur. Find the probability that the third win occurs on the 10th throw of the two dice. Now if you look with 10 throws, 4, 5, 6, 7, 8, 9. Here's the 10th one. We want the third win to occur on the 10th dice. All we know about the first 9 is that there are 2 wins and 7 losses. So we work out the probability of that. It's a Bernoulli trial. We don't know what order they come in. So N choose R. P is the probability of success. I'm interested in 2 successes, and I'm looking for R or N minus R failures. And then I have to multiply that by the probability of a win at the end. So N is the number of times I'm doing it. I'm doing this 9 times. Remember, it's only the 10th one that we leave out. So I'm looking for 2 wins. P is the probability of 1 win, which is 5 over 18. So I'm looking for 2 wins, and I'm looking for, so that's 13 out of 18. I'm looking for 7 losses. And then I'm looking for 1 win at the very end. So when you multiply all of that together, you should get 0.7, or sorry, 0.0 even. 0.0791 correct to 4 decimal places. This is the standard Bernoulli trial, the first part, but then we know it's a win on the 10th one, so it has to be a win. So the first 9, we're basically working out the probability of 2 wins and 7 losses.